We will convert now the rational number to a decimal form. A rational number means it may be given in a p by q form, that is in a fraction form. And we have to convert that fraction into decimal form. Let us see. Here is the first example, 1 by 2. How can you convert 1 by 2 into a decimal form? 1 by 2 means we have to divide 1 with 2. The denominator is 2 and the numerator is 1. Therefore, the numerator is to be divided by 2. That is, 1 is to be divided by 2. As 2 cannot divide 1, keep 0 point. Since you keep point here, you may write 0 on the right hand side to 1 so that it will become 10. In 10, 2 5 times. 5 2's 10. And if you subtract 10 from 10, you will get the remainder 0. Since the remainder is 0, the division is over. So that 1 by 2, the value of the 1 by 2 is equal to its quotient, that is 0.5. This 1 by 2 is in p by q form, and we converted this rational number into its decimal form, this is 0.5. Now another example, 1 by 5. Let us divide 1 with 5. As usual, 5 cannot divide 1, therefore equip 0 point. You can add the digit 0 to the right hand side of 1 so that it is 10. And in 10 now, 5 2 times. 5 2's 10. And the remainder is 0. Since the remainder is 0, the division is over. Now 1 by 5 is equal to the quotient 0.2. 0.2 is in decimal form. 0.2 is a decimal number. Now this 1 by 5 fraction, which is a rational number, is now converted into decimal form. And third example, 11 by 4. Let us divide 11 with 4 now. In 11, 4 2 times. 2 4's 8. And if you subtract 8 from 11, you will get 3. Now can you divide 3 by 4? You cannot. Therefore, keep a point and write 0. It is 30 now. In 30, 4 7 times. 7 4's 28. Subtract now. If you subtract 28 from 30, you will get 2. Add the digit 0 now so that it is 20. In 20, 4 5 times. 4 5's 20 and the remainder is 0. So that the division is over. Now 11 by 4 is equal to, here the quotient is 2.75. Understood? Now if you observe all these three examples, in all these three examples we converted a fraction, which is a rational number, into its decimal form. We got 0.5, 0.2, 2.75. All these three are terminating decimals. Isn't it? All these are terminating decimals. We got all the three cases, we got terminating decimals in all the three cases. Now if you observe its denominators, here the denominator is 2, here the denominator is 5, here the denominator is 4. 4 means it is 2 square. Now one point is, in any fraction, if it is a rational number, in any fraction if the denominator is in the form of 2 power n into 5 power m, then you will get a terminating decimal. Means 2 power n into 5 power n means the denominator should contain only 2 and 5 as factors. If you divide any denominator into its prime factorization, if we get only 2 and 5 as factors, then such rational numbers or such fractions should be terminating decimals. Understood? You see, you observe all these three fractions. In any fraction, if we divide the denominator into prime factorization, if the denominator contains only 2 and 5 as factors, in such cases, if you convert those rational numbers, you will get a terminating decimals. Now look at the second model. In second model, The first bit is 1 by 3. Here you observe the denominator. This denominator has neither 2 as a factor nor 5 as a factor. The prime factorization of 3 doesn't contain 2 and 5. In such case, what will happen? Let us see. We have to divide 1 by 3. 1 cannot be divided by 3, therefore keep 0 point and write 0 to the right hand side of 1 so that it is 10. In 10, 3 times. 3 3s 9. If we subtract 9 from 10, what is 10 minus 9? 10 minus 9 is 1. Now you keep 0 beside 1 so that it is 10. In 10, 3 times again. You will get 3 3s 9 again, and 10 minus 9 is remainder is 1. So that this division is not completed. Here in the first case 10 minus 9 is remainder 1, in the second case also 10 minus 9 remainder 1, in the third case also you will get 10 minus 9 remainder 1 and so on. Here this division cannot be completed even though you may do for so many times. That's why you kept 3 dots here, that is it is so on, etc. So 1 by 3, if you divide 1 by 3, you will get 0.333 and so on. Here it is repeating. This 3 is repeating. Therefore it is called repeating decimal. And at the same time there is no end to this division. Therefore it is non-terminating and repeating decimal number. If we divide 1 by 3, the quotient is 0.333 and so on. If we observe the division, division is not completed. Division has no end, so that its decimal part has no end. Since this decimal part has no end, it is called non-terminating decimal. And at the same time, we got 3 is repeating. Therefore, it is non-terminating repeating decimal number. Now observe the second example. 11 divided by 6. Now if we divide 11 with 6, in 11, 6 one time. 1 into 6 is 6. Now subtract 6 from 11. If we subtract 6 from 11, you will get remainder 5. Now keep point and add 0. It is 50. In 50, 6 8 times. 8 6 is 48. If we subtract 48 from 50, you will get the remainder 2. Now add 0. In 20, 6 3 times. 3 6 is 18. If you separate, again you will get 2. Isn't it? Here, in this case, the remainder is 2. If you separate again with 20, again you will get remainder 2. Therefore, this division is not yet completed. It cannot be completed even if you do this so many times. Therefore, 11 by 6 is equal to 1.8333 and so on. It has no end. Therefore, it is non-terminating decimal. And at the same time, this 3 is repeating. This part of this decimal is repeating. This 3 is repeating. Therefore, it is non-terminating and repeating decimal number. Isn't it? Now you observe these two examples. In any fraction, if the denominator contains only 2 and 5 as factors, then such rational numbers will be terminating decimals. And if the denominator contains the factors which are other than 2 and 5 also, such rational numbers are non-terminating repeating decimals. They are also called as non-terminating recurring decimals. Understood? Very good. You may practice some more such divisions at your own, and you may verify whether what we discussed is right or wrong. Thank you. Thank you very much.